screen. Let me stop my presentation. Can you present now?
Yes, sir.
Yes. Why Ilamagiri?
Sir, share ஆக மாட்டேங்குது.
See, wait a minute. Can you see the screen? Google Meet screen. There, can you right hand side you go? There you will find one menu called Present Now.
Yes, sir.
Click that one. So make the things slowly. Click the one Present Now icon. Then click Share Entire Screen. Can you follow? Then
share button visible ஆக மாட்டேங்குது sir.
Share button visible ஆகலனா கொஞ்சம் வெயிட் பண்ணு. நெட்வொர்க் கொஞ்சம்
இல்ல சார்
எஸ் ராமகிருஷ்ணன்
ஸ்கிரீனை கிளிக் பண்ண
எஸ் ஸ்கிரீனை கிளிக் பண்ணுமா கரெக்ட் நிரஞ்சனா கிளிக் தி ஸ்கிரீன் தென் only you will get the share option. அதுதான் உங்க ப்ரோக்ராம். If the click is enabled, okay, then enable the share button. அப்படிதான் கோடிங் எழுதிருக்காங்க. இப்போ புரிஞ்சிருச்சா?
சார் ஸ்கிரீன் பவர் பாயிண்ட் தானே சார் கிளிக் பண்ணனும்.
ஒண்ணும் இல்லம்மா, நீ என்டையர் ஸ்கிரீனை கிளிக் பண்ணு மேல. நிரஞ்சனா, I will repeat once again. Click present now.
Yes sir.
Click your entire screen.
Yes sir.
Now you one window will appear in front of you. Am I correct?
Yes sir.
Click that window.
Okay sir.
Is it share is enabled now? Blue color with blue color.
Yes sir. Yes sir.
Now you click share.
Yes sir.
The same
both
thing.
class visible sir.
Yes. Now one class is okay. Yes, both the classes is okay. Yes.
Okay sir.
Thank you.
Sorry sir.
No issue. Start.
Happy morning to all. This is Niranjana from CSE A. Let me see about PN junction diode. Yes sir.
Top fourth icon, shortcut icon. Top. One more layer up. அந்த மெனுக்கு மேல ஒரு மெனு இருக்கு பாரு.
இங்க தான் சார்.
கிளிக் பண்ணு.
Okay sir.
That's all. Yes.
Okay. Let me see about PN junction diode. Firstly, what is PN junction? PN junction is formed by joining P-type silicon material and N-type silicon material. When we join P-type silicon material and N-type silicon material, opposite polarity there will be exist. Due to opposite polarity, attraction will be existed. Due to this attractions, electrons from N-type and holes from P-type starts to move opposite side. Due to this movement, at the junction, P side immediate region occupies electrons. This becomes negative ion, fully negative ion. Then negative side immediate region, whole positive holes occupies. So it becomes positive ion core.
Yes, continue. Be cool and continue.
This p-type is made up of trivalent impurity atom, example boron, and n-type is made up of pentavalent impurity atom, example antimony. Due to this polarity developed, there will be exist opposing force. That opposing force is nothing but barrier potential. This barrier potential stops the further movement of holes and electrons from opposite side to another side. Here electrons are occupied fully and here holes are occupied full region in the immediate region. So it becomes a layer. This region is called depletion region. At the depletion region, immobile carriers only present. These are whole electrically charged, also called as this negative space charge region, and this is positive space charge region. The developed barrier potential depends on types of semiconductor, amount of doping, temperature. If we take a silicon material, the barrier potential will be 0.7 volt. If it is germanium material, the barrier potential will be 0.3 volt. Okay. Although the barrier potential developed due to this barrier potential, there is no movement of holes and electrons. If no, that can be, shall I tell in Tamil?
சார் அன்மியூட் பண்ணுங்க சார்.
நிரஞ்சனா, நீ சொல்றது எல்லாத்துக்கும் புரியுது. Please go with the same thing. Don't worry.
Okay, sir. Okay, sir. The developed barrier potential stops further movement of holes from p side and electrons from n side. When the movement of holes and electron takes place, there will be current produced. As a result of barrier potential stops the movement, there is no current produced. If we give a extra force to the p side majority carriers and n side majority carriers, there will take place a movement of holes and electrons. So we have to give a external force, that is called external voltage. The applying external voltage to a diode to make further movement of charge carriers across the junction is the bias. This process is called biasing. Biasing takes place two types, forward bias and reverse bias. What is the forward bias? When the positive terminal of the battery is connected to p side anode and negative terminal of the battery is connected to n side cathode, it forms a forward bias. When the applied voltage is greater than barrier potential, then only the electrons from n side and the holes from p side starts move across the junction. As a result, we get a current. If input voltage is less than barrier potential, there is no movement of holes, so there is no current. Current produced due to movement of both holes and electrons. Both holes and electrons movement இருந்தாதான் அங்க current produce ஆகும். But the direction of forward current is from A to K, that is anode to cathode. Only the direction of forward current will be processed. Next, movement of holes also produce one charge. Movement of electrons also produce from one charge, one current. If the holes move from anode to cathode, it produce current. Here holes are taken as majority carriers, electrons are minority carriers, because hole is the consists of protons, neutrons. The weight of the mass of the proton is high, electron of the mass of the electron is low. Higher mass carriers move fast, lower mass carriers move slow. As a result, holes movement produced one current which is taken as I majority, and movement of electrons produce one current that is taken as IS, saturation current. Saturation current is nothing but current produced due to minority carriers. From here, by Kirchhoff's law, IF, forward current equal to I majority minus IS is taken. VA characteristics of PN junction diode. Forward bias. If you take a silicon material up to 0.7 volt, that is barrier potential, there is no current flow across the diode. Above the barrier potential, only current flows. So, on which voltage the current starts to flow across the diode is taken as knee voltage. From here onwards, current abruptly increased across the diode. Reverse bias. When the negative terminal of the battery is connected to P side and positive terminal of the battery is connected to N side, it forms a reverse bias. Applied voltage, when the applied voltage is less than 0 volt, there will be no movement of charge carriers. If the applied voltage is greater than 0 volt, holes in P sides are attracted towards the negative terminal of the battery and electrons in the N side are attracted towards the positive terminal of the battery. As a result, P-type space will be reduced, N-type space also reduced, depletion region space is increased. Thus, majority carriers are drawn away from junction. Depletion width increases. As a result, opposing force produced in a depletion region. Barrier potential also increases. So, there is no movement of majority carriers across the junction. So, I t equal to 0 is taken. Even though depletion region increases, due to this barrier potential developed in depletion region, minority carriers present in both type are start to move across the junction. As a result, there will be produced one current, that is saturation current. Already we seen that saturation current is produced due to only minority carriers. So in reverse bias, only saturation current is produced. The produced saturation current is depend only on barrier potential, not on battery potential. Whether the battery potential is high or low, doesn't matter. Because the VB is produced, IS is produced due to barrier potential developed in a depletion region. VI characteristics of PN junction diode. Reverse bias. Up to some voltage, there will be a small current, that is saturation current, across the diode. After the breakdown, after some voltage, there will be current produced abruptly. This will damage the diode, and that is breakdown voltage. At the breakdown voltage, above the breakdown voltage, the diode damaged. Up to breakdown voltage, one current is produced, that is IS. If we take a silicon diode material, and the current produced in reverse bias is in the order of nanometer, whereas in germanium it is in the order of microampere. This breakdown voltage produce damage the diode. Hence, it is not applicable in normal situation. Hence, manufacturer calculate the one PIV, that is peak inverse voltage, that is maximum reverse voltage applied to the diode without breakdown. Before breakdown, At what maximum voltage the diode can produce current? So that is PIV, peak inverse voltage. Thank you.
Saji sir, Jagadish sir gave a immediate response. Done well. Yes. Dear students, if you are having any doubts, you can ask her. Even you can type your question in the chat box. Niranjana, wait for some time. Whether from our student side, if they are asking any doubts, try to answer. Okay. Yes. Can I even you can unmute and ask? இல்லை எனக்கு வந்து இது இந்த பாயிண்ட் வந்து எனக்கு தப்புன்ற மாதிரி தெரியுது அது மாதிரி இருந்தாலும் யூ கேன் ஃபர்ஸ்ட் யூ கிவ் யுவர் ஃபீட்பேக் தென் சஜஸ்ட் சார் அட் லாஸ்ட் மீ let me check orders are present. Actually he joined initially actually sir. Okay, no. Okay, can I கொஞ்சம் கேளுங்க நம்ம ஃப்ரெண்ட்ஸ்ட்டு தானே இன்னைக்கு ஒரு நாள் டீச்சர்ஸ் 4 பேர் இருக்கிறாங்க ஒரு டீச்சர் கிளாஸ் எடுத்துட்டாங்க ஆஸ்க் யுவர் டவுட்ஸ் எங்கள்கிட்ட கேட்கறதால உங்களுக்கு இதாக இருக்கு உங்கள் ஃப்ரெண்ட்ஸ்கிட்ட கேளுங்க ஏதாவது டவுட் ஐ வில் கம் பேக் வெயிட் நிரஞ்சனா ஐ வில் கம் பேக் ஆனால் எனி கொஸ்டின்ஸ் கேர்ள்ஸ் சௌமியா ஏதாவது டவுட் இருந்தால் கேட்கலாம்ல உங்கள் ஃப்ரெண்ட்ஸ்கிட்ட நோ டவுட்டா ஏன் நீ எடுக்கும்போது அவங்க கேட்பாங்க நீ இப்போ கேட்காம ஏதாவது பேசி வச்சிருக்கீங்களா சாக்லேட் வாங்கி தரேன் கேட்கக்கூடாதுன்னு இங்கே வேற ஏக்கா டவுட் இருக்கா எஸ் ஓகே சஜீஷ் சார்
சார்
எஸ்
எனக்கு டவுட் இல்லை சார் ஒரு சஜஷன்ஸ்
எஸ் 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 எஸ்
நிரஞ்சனா
எஸ் சார்
நீங்க போட்ட ஸ்லைட்ஸ்ல எல்லாம் ஜஸ்ட் டைட்டில் எதுவுமே போடல ஃபர்ஸ்ட் ஸ்டார்டிங் ஸ்லைட் எல்லாம் ஜஸ்ட் பிரசன்ட் பண்ண கொஞ்சம் ஸ்பீட் ரெண்டு கிளாஸும் பிரசன்ட் பண்ணணும் சீக்கிரம்
next yaar present பண்ணும் please make ready your slides. Who is the next? Hello. Okay.
Second slide.
Okay.
Yes sir.
Second slide எல்லாம் காமி. நீங்க முன்னாடி ஸ்லைடு ப்ரிப்பேர் பண்ணிருக்கா ஃபர்ஸ்ட் கிளாஸ்ல இல்ல ஒரு ஃபர்ஸ்ட் செமஸ்டர்ல
நானா சார்
ஆமா எக்ஸ்பீரியன்ஸ் இருக்கா ஸ்லைட் எல்லாம் போட்டு
ஒன் டைம் மட்டும் தான் சார் பண்ணிருக்கேன்
சரி ஓகே இது என்னோட சஜஷன்ஸ் நோட் பண்ணி வச்சுக்கோ அடுத்த டைம் கரெக்ட் பண்ணி போதும் புரியுதா
ஓகே சார் ஓகே
இங்க பாரு ஃபர்ஸ்ட் ஸ்லைட்ல டைட்டில் இல்ல கரெக்ட் தானே
என்ன சார்
ஹெட்டிங் டைட்டில் இன் சென்ஸ் ஒவ்வொரு ஸ்லைட்ல நம்ம ஹெட்டிங் போடும் கரெக்டா நாங்க எல்லாம் பிரசன்ட் பண்ண பாத்துருக்கேன் நீங்க நம்ம கிளாஸ்ல பிரசன்ட் பண்ணும்போது
எஸ் சார்
இப்போ நீங்க ஃபர்ஸ்டே வாட் இஸ் பிஎன் ஜங்ஷன் கேக்குது கரெக்டா அதே மாதிரி அதுக்கு முன்னாடி ஒரு ஹெட்டிங் ஸ்லைடு இருக்கும் ஓகே அது நீங்க போடல கடைசி ஸ்லைட்ல ரிவர்ஸ் பயாசிங் நீங்க டைட்டில் போட்டுருக்கு அடுத்த ஸ்லைடு போங்க கடைசியில அதான் இப்ப இங்க பாரு ஃபார்வர்ட் பயாஸ் ரிவர்ஸ் பயாஸ் விஏ கேரக்டர்ஸ் எல்லாம் போட்டுருக்கா இங்க போட்டுருக்கா
எஸ் சார்
இந்த விஏ கேரக்டர்ஸ் ஆஃப் பிஎன் ஜங்ஷன் டையோடு போட்டது அந்த ஸ்லைடோட ஹெட்டிங் கரெக்டா அதே மாதிரி
ரிவர்ஸ் பயாஸ் அடுத்த ஸ்லைட்ல போட சொல்றீங்க சார்
ஃபர்ஸ்ட் ஸ்லைடில் போட்டுருக்கு இல்ல மேடம் எல்லா ஸ்லைடிலும் இந்த
வாய்ஸ் பிரேக் ஆகுது
நிரஞ்சனா வாட்ஸ் ஹலோ நிரஞ்சனா
எஸ் சார்
அதாவது ஸ்லைட்ஸ்ல ஹெட்டிங் ஃபார்வர்ட் பயாசிங் போட்டுட்டா அதோட consecutive next slide forward bias you can keep the same name or simply you type continue.
Forward bias இந்த ஸ்லைட்ல ஹெட்டிங் சார் கேக்குதா?
Okay.
Okay,
Sir, suggest sir, voice break ஆகுது. நான் சொல்றேன் சார், நீங்க சொல்றது.
ஓகே சார், ஓகே சார்.
Can I see what sir is saying there? Every slide should have a title.
Okay,
Clear?
sir.
Forward
Okay.
bias. If you are taking the same content in the consecutive slide also, you can keep the same title, no issue. Or else, continued again you can type. Okay?
Okay, sir.
That is the first point sir want to convey. Okay, sir, suggest sir. Next.
சார், ஸ்லைடு நம்பர். ஜஸ்ட் சிம்பிள் ஸ்லைடு நம்பர் போட்டதா நமக்கு ஜஸ்ட் இந்த ஸ்லைடுல இந்த மிஸ்டேக் இருக்கு அப்படி சொல்ல முடியாது. இல்லைன்னா நமக்கும் தெரியாது, நம்ம எந்த ஸ்லைடு சொல்லணும் நமக்கும் தெரியாது, அவருக்கும் தெரியாது.
Okay, sir. Slide number. Okay, sir. Okay, sir. Bottom side.
அது ஒரு செட்டிங்ஸ் இருக்கு, அது நீங்க தெரியும், பார்த்தாலே தெரியும். நீங்க போட வேணாம், அது ஒரு செட்டிங்ஸ்ல சேஞ்ச் பண்ணல ஸ்லைட் நம்பர் வரும். ஓகே.
Okay, sir.
அப்புறம் இது வந்து பிபிடி தானே, பவர் பாயிண்ட் பிரசன்டேஷன். ஓகே. இப்போ ஃபர்ஸ்ட் ஸ்லைட்ல எல்லாம் நம்ம உங்களுக்கு ஸ்டடி மெட்டீரியல் கிடைச்சிருக்கு கரெக்டா, ஹேண்ட் நோட்ஸ் கிடைச்சிருக்கும். அதுல எல்லாம் நம்ம இங்க இப்படி சென்டென்ஸ் பை சென்டென்ஸ் இப்படி போட்டுட்டே இருக்கு கரெக்டா. அதே மாதிரிதான் நீங்க ஒவ்வொரு ஸ்லைடும் போட்டு அப்படி போடுறதுக்கு பதிலா ஜஸ்ட் ஒரு பாயிண்ட்ஸ் மட்டும் போட்டுட்டு அந்த பாயிண்ட் எக்ஸ்பிளைன் பண்ணி நல்லா இருக்கும்.
பாயிண்ட் போட்டு சொல்லுங்க.
இப்போ ஃபர்ஸ்ட் ஸ்லைட் எல்லாம் ஃபுல் ஒரு சென்டென்ஸ் மாதிரி தான் இருக்குது பாக்குறதுக்கு. ஓகே. வேற மெயினா ஒரு விஷயம், பயம் வேணாம். புரியுதா? நீங்க ஃபர்ஸ்ட் எல்லாம் ரொம்ப ரொம்ப பயந்துதான் பேசியது, அது நல்லா தெரியுது. உன்னை யாருமே இங்க எதுவுமே சொல்ல மாட்டேன், இப்படிதான் நம்ம பிராக்டிஸ் பண்ணுது. புரியுதா? ஓகே. சோ பயப்பட்டுட்டு எதுவுமே எடுக்க வேணாம். புரியுதா? பயம் மறந்துடு. ஓகே. நீ கிளாஸ்ல எப்படி உட்கார்ந்துட்டு இருக்குமோ அதே மாதிரிதான் நீ பிரசங்கம் பண்ணணும். புரியுதா? பயப்பட வேண்டாம், யாருக்குமே எதுக்குமே பயப்பட வேண்டாம். புரியுதா? சப்போஸ் ஏதாவது தப்பு சொன்னா அது நாங்க கரெக்ட் பண்ணி கொடுப்போம். புரியுதா?
ஓகே சார்.
பயப்பட வேண்டாம் இனிமே. ஓகே, ஃபைன், அவ்வளவுதான், மத்தபடி வேற எதுவுமே இல்ல. ஓகே.
சாரி சார், ஃபர்ஸ்ட் டைம் நல்லா திக்கிருச்சு ரொம்ப.
அது எல்லாருக்கும் இப்ப ஈவன் நான் ஃபர்ஸ்ட் இயர்ல நான் இப்படி இருக்க மாதிரி இருந்தா எனக்கும் அப்படிதான் வெளியா, அது எல்லாருக்கும் அப்படிதான். போக போக சரியாயிடும், போக போக சரியாயிடும்.
Okay, sir.
Yes. Niranjana, I have few points. Collectively, I will tell you at the end of the session. Okay.
Yes, sir.
Only one thing. Excellent presentation. Okay. Thank you.
Thank you, sir.
Yes. Next one. Dear students. Yes.
In the both classes.
You ask your friends. I am today absent for some time.
Okay.
I think you need to unmute in another class. Check it.
Hello, can you hear me?
என்னடே ஒரு ஜீவன் கேக்குதேடா, ரிப்ளை பண்ணுங்களேடா.
கேக்குதுன்னு சொல்ல வேண்டியதானே, அப்பதானே அவனுக்கு தெரியா.
இருங்க, அவனுக்கு இன்னைக்கு தெரியும் நம்ம நிலைமை எப்படின்றது.
Is my presentation visible on the both class?
தம்பி visible, screen visible இருக்கு. நீங்க அந்த PPT போங்க, PPT ஓபன் பண்ணிட்டு அங்க
சஜித் சார்.
Okay, sir. Okay. Okay. Good. Can I start, sir?
Yes.
Good morning. I'm going to take a seminar on Zener diode. Okay. First, why do we need a Zener diode, or what is the use of Zener diode?
தம்பி PPT பிரசன்ட் ஆகல, இந்த கிளாஸ்ல PPT பிரசன்ட் ஆகல.
As one second, sir. Which section?
Yes,
sir?
A கிளாஸ்ல பிரசன்ட் ஆகல.
A present ஆகல, sir. Okay.
இப்போ ரெண்டிலும் பிரசன்ட் ஆகல.
One second, sir. Now, sir,
A,
is it visible, sir?
no,
ഇപ്പൊ
A, A class.
എയില് നീ പ്രസന്റ് കൊടുക്കല്ലേ, എ ക്ലാസ്സിൽ ലിങ്കിലും പ്രസന്റ് എന്റെ സ്ക്രീൻ കൊടുക്കും പണ്ടല്ലേ നിനക്ക്.
One second, sir. Now it is visible on the board. Hello, sir.
பி கிளாஸ்ல விசிபிளா இருக்கா சார்?
No, no, B ல not visible. டேய், உங்க ஃப்ரெண்டு கேக்குறான், யாரோ ஒருத்தன் வாயை திறந்து ஹெல்ப் பண்ணுங்கடா. தூங்கிட்டு இருக்கீங்க.
சார்
கண்ணா அவரோட ஐகான் பின் பண்ணிருக்கீங்களா பாருங்க. ஹலோ, எவ்ரிஒன் ப்ளீஸ் பின் 122 ஐகான். கண்ணா A classல I think we're able to see. விசிபிளா இருக்கா?
ஏழு விசிபிளா தான் சார் இருக்குது. பி கிளாஸ்ல பின் பண்ணாலும் வரல.
B ல தான் நான் சரி B ல நாட் விசிபிள். ஹலோ ஹலோ,
கேக்குது சார், கேக்குது.
இல்ல ஜஸ்ட் மைக்.
I will just.
Yes, you disconnect and rejoin in B class once again. Yes, yes. கலைமாறன் இப்பதான் டீ சாப்பிட்டு கமெண்ட் கொடுத்துருக்காரு.
நெட்வொர்க் இஷ்யூவா இருந்துச்சு சார், அதனால தான் சார். ரீஜன் லெஃப்ட்
சரி சரிடா, ஓகே. இப்போ நெக்ஸ்ட் நீ எடுத்துறியா மாடியூல் 2? Else, shall we go with the third person and come back? Yes, yes, yes. Now he's doing some magics. Okay, anyhow, we have 40 minutes more in hand. Now B visible, A also visible.
Okay.
Yes, thank you. Start.
Good morning on Zener diode. So first we will look into why do we need a Zener diode, or what is a Zener diode. As Niranjana was saying that in reverse bias condition, it was an open circuit, the current didn't flow. So to rectify that, we use Zener diode. Zener diode is similar to PN junction, but the difference is it is highly doped, so that the depletion region is very narrow, and so that it could be used in the reverse bias condition without taking damage. This also the this side is anode and cathode. When positive, for the reverse bias, it is opposite. The anode is connected to the negative.
Hello, who need to present next? Hello,
Sir.
Lakshana, are you ready?
Yes, sir.
Oh, you continue.
Yes, sir.
You proceed. If he comes back, we will take it in the next slot. Okay. Now you continue.
Yes,
Do
sir.
you have?
1 second.
Yes, yes. Kind of PowerPoint presentation is a very old software, but it is getting updated every year. Okay, so try to learn that one. Very simple. It is one of the Microsoft Office tool. Uh, I think you are aware of MS Word. Am I correct? Lakshana, are you
Yes, sir.
making the attempt? Lakshana, are you making
Yeah.
the attempt? Okay.
Yes, sir.
But yes, do it. If you need any help, how to use the PowerPoint and all, you can approach your faculties. Else even you ask us, we will guide you. You have plenty of YouTube videos too for your self-learning. Do practice this, okay? See, if you want to deliver something, the first and foremost weapon what we are using is the PowerPoint, okay? Sales meeting, industry level, we will find the same software. Do practice in that. Sedha Ramalingam, are you ready with your things?
Yes, sir.
Okay. Once Lakshana finished, you come back. You will be the next one. Then we will go with Jaisu last. Lakshana, please.
So sorry, sir. 1 minute, sir.
Yes. Lakshana, you need any help, please interact. We will help you.
Yes, sir.
Are you in the Google Meet now? In the laptop or mobile phone?
Laptop,
Can you
sir.
find the icon? Yes. Listen, no, okay. One
Sir, can I have the link for A class, sir?
link. Sure, I will give you. You need a class link. Yes. Please check the chat box.
Yes, sir.
I hope everyone is watching how to share the screen. Am I correct? B class students?
Sir, is it visible in both the
Yes.
classes, sir?
Now you open your presentation. Yes. Click hide icon and click slideshow mode, the top fourth icon. Yes. Yes. Click slide mode, top top fourth icon. Go up. Yes. Yes, yes. Click hide button. Please click hide button at the down. Yes, start.
Sir, in B class, we can't hear anything.
We can't hear, sir.
Hello, wait a minute. Go to B class window. Hello. Go to B class window, and the right hand side you will find 3 dots, more options. Click it. B class. You have to close your PowerPoint first. Lakshana, give escape button. Click escape button. Yes. Open Google Meet. Go to A class first of all. Go to A class.
Sir,
Click.
ஒரே நிமிஷம். அவர் மைக்கே ஆன் பண்ணல.
Mute. Okay. மா unmute. அது மியூட் பண்ணிருக்கு பாரு. அதை unmute பண்ணுங்க.
B class மைக் ஆன் பண்ணி விடுங்க.
ஐயோ.
அப்போ ஒரு கிளாஸ் மட்டும் தான் சார் கேட்கும். அப்படி இருந்து ஒரு கிளாஸ்
தான் கேட்கும். Students, okay, you can hear her voice in the recording. Okay, A class students. Yes, ma, you continue. Yes. Yes. Dear students, any questions? Sorry, sir. Yes, sir. Yes, sir. Lakshana? Thank you, sir. Sir, I have noted down few points, sir, that we will. I plan to discuss at the end, sir. Hello, sir. Yes. Yes, sir. Yes, sir. I am also noted down the same points, sir. Yes, sir. Thank you, sir. Next is Seetharamalingam. Yes. Lakshana, yes, Lakshana, can you stop your presentation? A class students, don't worry. We will share you this recording. Thereby, you can listen her audio how she presented. Okay? A class student.
Sir, B class da sir.
B class. B.
A
Okay,
class.
okay. B class. We will share you her total recording. We will post it. Watch it. Okay.
So shall I start my presentation?
Yes, 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 yes.
Sir, presentation is visible in both classes, sir.
Yes. Yes.
So now is it visible, sir?
Yes, yes. Please.
Good morning, sir, and my friends. Today here I am to take a seminar about regulated power supply. Yeah, DC supply. First I explain about the DC power supplies. The DC power supply is the one that maintains a constant output voltage irrespective of input voltage fluctuations or load variations is known as regulated DC power supply. It is generally classified into two types: linear regulated power supply and switched mode power supply. Here we are about to learn about linear regulated power supply. Linear regulated power supply. It is an electronic circuit that converts the AC main supply into required constant DC voltage, irrespective of the change in load current and line voltage. It has five components, namely step-down transformer, rectifier, filter, voltage regulator, and load. Step-down, we all know that transformer is a passive electrical device that transfers electrical energy from one electrical circuit to another or multiple circuits. The step-down transformer is the one that converts AC high voltage into AC low voltage at required level. And rectifier is a circuit which converts bidirectional AC voltage or current into unidirectional pulsating DC voltage or current. Filter removes the unwanted ripple contents from the pulsating DC voltage. Regulator, it gives a steady DC output even if the input voltage and load current varies. Here we are going to briefly learn about rectifiers. Before knowing about the rectifier, we must know the explanation of rectification. The process of converting the alternating current into direct current is known as the rectification. The device used for the process of rectification is known as a rectifier. Rectifier is defined as an electronic circuit which is used for converting AC voltage into unidirectional DC voltage. Depending upon the period of conduction, the rectifiers are classified into two types: half-wave rectifier and full-wave rectifier. The unidirectional conducting property of the diode finds great application in rectifiers. First of all, we learn about half-wave rectifier. Half-wave rectifier circuit consists of an AC supply, a PN junction diode, and a load resistor. In half-wave circuit, either a positive or off or negative half of the input is passed through, while the other half is blocked. Here, PN junction diode acts as the rectifier diode, converting alternating voltage or current into pulsating DC voltage or current during one half of the applied input Vin. This is the overall circuit diagram of the half-wave rectifier. Here, as I mentioned above, an AC supply, one PN junction diode, and a load resistor to the ground. Operation of half-wave rectifier circuit. First, when the positive half cycle of the input voltage passes, from the circuit diagram below, the polarity, that is the direction of current, makes the taken PN junction diode forward bias, and thus the diode conducts and current IL flows through the load resistor RL. Since the forward biased diode offers a very low resistance, the voltage drop across it is very small. The voltage appearing across the load terminals is ideally same as the voltage V at every instant. But during the negative half cycle of the input voltage, the direction of the current gets reversed, and therefore the diode is now reverse biased and no current flows through the circuit. Therefore, no voltage developed across the load resistance RL. From this waveform, we can learn that when the first half of the input voltage is passed, the diode conducts the electricity, and when the negative half cycle takes place, it has no waveform because there's no conduction of current, output current. So therefore, it is known as half-wave rectifier. And next, we learn about full-wave rectifier. In a full-wave rectifier, unlike the half-wave rectifier, it utilizes both the half cycles, that is positive and the negative half cycles. Alternate half cycles are inverted to give you a unidirectional load current. The full-wave rectifier circuit consists of 2 PN junction diodes in the case of center tapped rectifier, and 4 PN junction diodes in the case of bridge rectifier. A center tapped transformer in center tapped rectifier and a load resistor. It is common. The full wave rectifier is further classified into two: center tapped full wave rectifier, bridge full wave rectifier. First of all, center tapped full wave rectifier. In center tapped full wave rectifier, only 2 diodes are required for converting single phase AC supply into full wave pulsating DC. The full wave rectifier conducts during positive and negative half cycle of input of AC supply. In order to rectify both half cycles of AC input, 2 diodes are used in the circuit. And here we observe the circuit diagram. As I told, it has a center tap transformer here, 2 diodes, 2 PN junction diodes, and a load resistor. In full wave rectifier circuit, both half cycles are utilized. First, during the positive half cycle of the input voltage, diode D1 and the diode D2 reverse bias. Diode D1 is forward bias and diode D2 is reverse bias. The current flows through D1 and then comes here to the load resistor and upper half of the winding. So therefore, the first half cycle is gets utilized and conducts the current. And also during negative half cycle of the input voltage, the diode D2 is forward biased and diode D1 is reverse biased, and therefore the polarity of the current, polarity of the circuit is from D2, then comes to here load resistor, and then a lower and completes the lower half of the winding. From this, we can conclude that full wave rectifier circuit utilizes both the halves and gives a constant DC voltage. And also observe the waveforms here. Same, both the input forms give constant DC output. And bridge full wave rectifier. The need for a center tap transformer in a full wave rectifier is eliminated in the case of bridge rectifier. But in addition, it carries more current than center tapped full wave rectifier. So therefore, it is the modern and widely used full wave rectifier in our daily applications. And circuit diagram, as I mentioned in the first, it has 4 PN junction diodes and a load resistor, but it has no center tap transformer. That's no need. In here, during the positive half cycle of input, the point A is positive, more positive than B, and thus the diode D2 and D3 are forward biased, and the diode D1 and D4 are reverse biased. Then the current ID2 and ID3 flows through the diode D2 and D3, the load RL, and through D3 back to the negative polarity of the AC input signal. Here the path is A, point A, D2, then load resistor RL, then to D3, then finishes to C. During the negative half cycle of the input, point A is positive than point B, thus diode D1 and D4 gets forward bias, and diode D2 and D3 gets reverse bias. Then the current ID1 and ID4 flows through the diode D4, the load diode D4 first, and comes to flows from the C, comes to the diode D4, then goes to the load resistor RL, then it passes to the diode 1 and exits. Here, same as the center tapped full wave rectifier, it also gives the constant output, unlike of a half wave rectifier. So therefore, full wave rectifier is a widely used rectifier to get the constant output current. Before seeing the comparisons, we must know what are the terms and definitions we use in both the rectifiers. Average load current, IL, it is denoted as ILDC. ILDC is the average or the current, DC current flows through the load resistor RL. Average load voltage, VLDC is the average or the DC voltage developed across the load resistant RL. RMS, root mean square value of load current, IL RMS. The RMS or effective value of the current flowing through the load resistor. RMS value of load voltage, it is denoted by VL RMS. RMS value or effective value of the voltage developed across the load. Ripple factor, it is defined as the ratio of RMS value of the AC component in output waveform to the DC component in the output waveform, and it is denoted by the symbol gamma. Rectifier efficiency, it is denoted by the symbol neta. Rectifier efficiency, it is the ratio of output DC power supplied to the circuit. Efficiency defined as the ratio of output DC power supplied to the circuit. Peak inverse voltage, it is defined as the maximum reverse voltage that a diode can withstand without destroying the junction. Comparison of rectifiers. In this table, I have listed the common comparisons of the two rectifiers. We use only one PN junction diode in the half-wave rectifier, but in full-wave rectifier, we use two PN junction diodes in the case of center tapped rectifier and four PN junction diodes for bridge rectifier. Maximum load current in half-wave rectifier, it is calculated by a formula IM equal to VM by RF plus RL. in the case of full-wave rectifier, for bridge rectifier, IM is equal to load current is equal to voltage divided by 2 RF, 2 times the RF plus RL. In the case of center tapped rectifier, this calculated by VM divided by the sum of RF and RL. The average load current ILDC is calculated by dividing the maximum load current by pi, that is 3.14 or 22/7. In the case of full wave rectifier, it is the twice of the half wave rectifier, that is 2 into IM by pi. The same as the average load voltage. Here the difference is we divide the VM by pi. In the case of full wave rectifier, it is multiplied by 2 as the half wave rectifier. And here RMS load current, it is calculated by dividing the maximum load current by 2. And in the case of full wave rectifier, we are dividing the maximum load current by the square root of 2. RMS load voltage, VL RMS, VM by 2. And here same as we see in load current IL RMS, VM is divided by square root of 2. And here comes the rectifier efficiency. The rectifier efficiency of half wave rectifier is 40.6, whereas the full wave rectifier is 81.2. In other words, we can say that the efficiency of the full wave rectifier is approximately or equal to the twice of the efficiency of half wave rectifier. Ripple frequency or output frequency is denoted by Fin and 2Fin. Peak inverse voltage or PIV is the VM For it is same for bridge rectifier and half wave rectifier, but we have to multiply by 2 for center in the case of center tap rectifier. Thank you. Sir.
Yes. Sajid sir.
Yes, sir.
Hello,
Yes,
sir.
sir.
Actually, yesterday or day before yesterday only, Sedramalingam got the title.
தம்பி
Sajid sir.
சேதுராமலிங்கம் கேக்குதா தம்பி? எஸ் சார் எஸ் சார். தம்பி எனக்கு ஒரு சின்ன கொஞ்சம் சஜஷன்ஸ், அது அடுத்த பிரசன்டேஷன்ல கரெக்ட் பண்ணுங்க. ஜஸ்ட் ஸ்லைடு நம்பர் எல்லாம் போடுங்க எல்லா ஸ்லைடுக்கும். அப்புறம் ஸ்லைடுக்கெல்லாம் மீன்ஸ் ஹெட்டிங் நிரஞ்சனைக்கு சொன்ன மாதிரி ஸ்லைடுல எல்லாம் ஹெட்டிங் போடுங்க. ஃபர்ஸ்ட் ஒன்னும் இல்லாம நினைக்குது, ஒரு சிலருக்கு இருக்கு, ஒரு சிலருக்கு இருக்கு, ஒரு சிலருக்கு இல்ல, எல்லாத்துக்கும் என்ஷூர் பண்ணும். ஓகே, அப்புறம் ஆபரேஷன் எல்லாம் அதான் எக்ஸ்பிளைன் பண்ணி எப்படி யூஸ் பண்ண தெரியுமா? ஃபுல் ஸ்கிரீன்ல போடுமா?
Sedramalingam, whenever you are putting full screen, you can use marker pen. Understood? Sajid sir, your voice is getting. Sajid sir, wait a minute sir, your voice is getting breaking. I will convey the same. Sedramalingam, have you seen the Lakshana presentation? Then wherever you want to highlight some points, actually we explain all the details in the table very clearly.
Okay sir.
But the viewer can't see where you are pointing. Am I correct, Sedramalingam? At the time you can highlight those parameters. That is the point Sajid sir trying to convey. Okay. Yes. Okay. Jason, are you present now? We will do one thing. Gina diode presentation, we may have it some other day. Okay? That we will plan. Else you do one thing. You record your presentation and give it to us. Okay? I will suggest few recording tools. In that way we will try one presentation offline. Shall we try that one, dear students? Let him make a recording, then we will watch. OBS, you know. I'm really happy. Yes.
ரொம்ப அட்வான்ஸ்டு சார்.
Okay, it is the time conclude the things. Others they are very much advanced than us. Yes, கண்ணா இங்க பாருங்க, ஒரு 2 நிமிஷம் பசி பொறுத்துட்டு இருக்க முடியுமா? Let me conclude these things. நான் நிறைய எஃபர்ட் போட்டு உங்க ஃப்ரெண்ட் பண்ணிருக்காங்க. If I tell few points that you will note down. First of all, we are really happy about your the commitment, what you have heard, and the way in which you prepared your slide, and the way you tried to present it. Many of them I have, Lakshana may have previous experience, even Sedramalingam also. Am I correct?
Yes, sir.
You people have some experience. That's why we are telling only the experience will make men perfect. It's not said by me, somebody else. So Niranjana now got practiced much. If whoever sitting other side, if the same kind of thing is given to in the industry, now these people are expertised in this. Am I correct? So whenever you get a time, whenever you are getting the chance, try to catch it. Okay. Actually, the Google form, what I have shared, it is left open still. If you are registering for module 2, that will be taken into account for the module 2. You will find on time and we will have the presentation. Okay. Then the individual suggestions. The first one, Niranjana. See, I am not going to point all the things. The very, very important things that students should not return in their answer sheet. Those kind of mistakes only I will point 1 or 2 points in short. The first and foremost thing, current flows through the circuit, not across the circuit. Am I correct, Niranjana? Across edhukku use pananum? Voltage. Am I clear? That is the first one. And one thing, it is a you pointed the saturation current. There you are having little confusion, and you yourself also quoted in this consecutive lines the current due to minority carriers. Okay, don't spell there electron and hole and get confused. Okay, simply spell it is due to minority carrier. And also one blunder mistake, it is a nano ampere. It is not a nanometer. You spelled in somewhere. No, that you need to correct. You knew that very good, very good. And one more thing, we found computer science students slide. Where you find the comment line, C program double slash. அது வந்து தியரி பேப்பர்ல அப்படி எழுதக்கூடாது. ஓகே, whenever this is common to everyone. நீங்க ஆன்சர் எழுதும்போது இப்படி டபுள் ஸ்லாஷ் போட்டு எழுதக்கூடாது. பிராக்கெட்ல எழுதலாம், இல்ல லைன்ஸ்ல பிரேக் பண்ணி எழுதலாம். ஓகேவா? Yes, that is regarding Niranjana. Then come to Lakshana. As I told already, this may be the confusion for remaining students also. Please do remember one thing: regulation is different, regulators is different. Okay, regulation is the phenomena, regulator is the component and circuits. Is it clear? Resistor ku resistance ku different irukakana. Resistor அப்படினா என்னது? It is a component. Resistance அப்படினா property of the resistor, that you don't get confused. Then Niranjana, are you there? Yes. In the shunt regulator, Zener regulator, whenever you are increasing the voltage, obviously the load current will get increased, but we are not going to adjust the Zener diode current. The Zener diode itself adjusts its current. Why? That is its characteristics. Am I correct? Am I correct, Lakshana? We are not going to touch IZ current. We don't have any control there. Simply we'll give the input voltage. By the nature of the Zener device, that will regulate the current based on the voltage. Okay. Yes. The last but not least, Sedramalingam. Okay. Before that, Jesu, it's a good attempt. What I need to quote in his within a 2 minutes presentation. Before starting his presentation, can anyone observe? He made the continuity between the topic. Am I correct? Is it anyone note down that? Yes. So Niranjana vadha அவர் கன்வி பண்ணார். எப்படி கன்வி பண்ணார்? Can anyone tell me? Reverse breakdown la we can't use the PN junction diode. Now I am having a new product, that is Zener diode. Adu mari dana vandar. Am I correct? Yes. That you may record in the same thing in your recording also, you give it. Okay. Yes. I think, and one more thing, are you having a PPT or PDF in your hand? Make use of PPT. Okay. Yes. Now Sedramalingam.
Sir.
லேட்டா வந்தாலும் கொஞ்சம் லேட்டஸ்டா நிறைய கவர் பண்ணிருக்கேன். டயர்ட் ஆகிற அளவுக்கு எடுத்துட்டேன். கரெக்டா? தண்ணி பக்கத்துல வச்சிருக்கியா? தண்ணி குடிச்சிட்டியா?
இல்ல சார்.
தண்ணி எப்பவுமே பக்கத்துல வச்சுக்கணும். நான் ஒரு வாட்டர் பாட்டில் எப்பவுமே வச்சிருக்கேன், பாக்கலையா?
சார்.
வச்சுக்கணும். டிரான்ஸ்ஃபார்மர் டெஃபினிஷன் எங்க படிச்சீங்க நீங்க?
விக்கிபீடியா சார்.
Excellent. Yes. Transformer definition, what he quoted? Please everyone go to the recording and rewind and check the definition. உங்களுக்கு ஒரே ஒரு சின்ன கரெக்ஷன் என்னன்னா, yes, during reverse biased condition, current reverse ஆயிருக்குமா இல்ல voltage reverse பண்ணிருக்குமா?
சார் ரிவர்ஸ் பயாஸ் கண்டிஷன் இது ஃபார்வர்ட் காமனா கேக்குறீங்களா சார்?
In general.
In general, sir.
Alternate, if you apply the alternating waveform, which one is the input, voltage or current?
Direction of the current is diode is reverse bias. Direction of the current is get reversed.
Direction of current. Actually,
that is
okay, may I ask one thing? நம்ம வீட்டுக்கு voltage input வருதா current input வருதா? Okay, let me conclude, don't take much time. There we need to spell as the polarity of the voltage getting reverses. Okay.
Okay, sir.
Okay, voltage nala da current flow irukku. Who is the cause, who is the effect, you should keep in mind. That's all. And one more thing, yes, full wave rectifier, the advantage while you quoting, it won't give constant DC voltage. Angayum ripple irukku. Am I correct? It is not a still constant voltage. Still it has constant DC voltage. Now what we need to do? We need to use filters and regulators. Okay. With this, let me conclude today's seminar class. We will share you this recording. Please show to your parents. Okay. Thank you very much. Any doubts from your side? Sorry, I took more than 10 minutes. Don't angry with me.